video is produced for the purposes of the Erasmus Plus KA2 project entitled Teaching and Learning Microcontrollers via PBPinVET. This video is about the sensor module which was developed by the Greek team, the second EK of Piraeus. Within the project, we developed the sensor module training kit, which is an educational tool. It will help explaining how we can use a sensor in a circuit. We used the microchip controller PIC16C54. A sensor is the interface between the environment and the circuit. It receives information by measuring values in a physical scale. These values include properties like pressure, position, temperature, acceleration, etc. Sensors can be found in many everyday objects. A good sensor must obey the following rules. It must be sensitive to the measured property. It must be insensitive to any other property likely to be encountered on its application, and it must not influence the measured property. The main basic characteristics of a sensor are linearity, accuracy, error, full-scale input and output, sensitivity, resolution, hysteresis, delay, dead zone, etc. Some basic common used sensors are the LDR photoresistor, the temperature sensor, the ultrasonic sensor, the motion sensor, the vibration sensor, the gas sensor, the sound detector, and many more. Our sensor module training kit uses a LDR photoresistor as input sensor and a 3-digit display as output. We choose the PIC16C54 as microcontroller, and it consists of 3 subboards. These 3 subboards are the 3-digit display board with the PIC included, the photoresistor board and the power supply board. We choose to have the 3 subboards because it's easier to design, implement and understand the whole circuit, and it can be a basis for future projects. Our first board is the 3-digit display board. It's a circuit very useful for accurate event counting. The heart of the circuit is our PIC16C54 microcontroller. Each time an event occurs, an internal register in the PIC is increased and displayed, and there is also a reset button. Our Photoswitch board consists of a LDR photoresistor, which is our input sensor, whose sensitivity can be controlled by the trimmer. Our very simple power supply board uses a 7812 voltage regulator to keep the output voltage at 12 volt. The construction of the kit included 5 steps. The first step was to design the circuits using the microsim software. We took in mind that these circuits can be used for future projects. These are the diagrams of our 3 subboards. Step 2 was writing the code in PBPBasic Pro using the PBPBasic Pro compiler. Step 3 included manufacturing the boards and programming the PIC. To ensure better quality and durability, we had our boards professionally manufactured. Step 4 was about constructing the boards by soldering them carefully according to the diagrams. Each board was carefully tested. The last step was about assembling the complete kit. We constructed the kit using a wooden board in order to bridge and join the 3 subboards. Finally, we tested the functionality of the complete kit using a toy car. Thank you for watching our video.